Hello, ladies and gentlemen. Let's go through an example on gravity. Alright? I'm going to read the example for us so we're all on the same page. We all know what we're talking about here. Okay? We've got this one. A ball is thrown straight up in the air with an initial velocity of 25.0 meters per second. What is the ball's position, velocity, and acceleration each second for the first 5 seconds of its motion? Okay? So, the situation is, well, this, right? Ball is tossed straight up into the air, comes straight back down, right? One-dimensional motion in what we'll take as the y direction. And the question is just asking us, each second, where is the ball, what's its velocity, and what's the acceleration? So after 1 second, the ball's position will be right about here. After 2 seconds, maybe here. After 3 seconds, here. 4 seconds, 5 seconds. We're just going to do that. Okay? Always best to start off with a diagram. So let's do that. Alright. So remember, the ball goes straight up and straight back down. Now remember, this is not a diagram of the actual motion of the ball. The actual motion of the ball is straight up and straight down. This just helps us see the upward direction and the downward direction a little bit separate from one another. So let's start off by choosing a reference frame. And remember that when we've got a ball going up and down, it's a little bit easier to take the reference frame with the upward direction being positive and the downward direction being negative. So, we've got our reference frame chosen. Upwards is positive, downwards is negative. Now we can see that when we talk about the velocity being positive 25.0 meters per second, we mean in the positive y direction. Right? So, that's something that's been given to us. All right? The initial velocity is 25 meters per second. All right? Well, we don't know too much else about this. We can infer some things. One thing, this is an object in free fall, so the acceleration on it is the acceleration due to gravity. Get that in there. Negative 9.80 meters per second squared. We know that it's negative because, well, acceleration is going downwards in this case, right? Towards the negative y direction. We also know, well, we can choose where we want it to start from, and why wouldn't we have it start from 0? So we'll have y naught equals 0 as well. At this point, what we really need to do is just find out, okay, well, is there an equation that we can use that has y naught, v naught, g, and a final position? And we can see that fairly easily, right? Is going to be something like so. Y Alright, y is equal to y naught plus v naught t plus 1/2 gt squared. Nicely enough, we know the acceleration of the object. It's the acceleration due to gravity. We know the initial position is 0. And we also know the initial velocity. We know those already. The last thing to do is just substitute the values for t each time. Okay? I'm going to do it just once for 1 second, and then I'll just give you the answers for what comes afterwards. Right? So, the object's position after 1 second is going to be 25.0 meters per second times 1 second plus 1/2 1/2 times 9.0 meters per second squared times 1 second squared. Alright, if we put all these values in, we're going to get a y position of 20.1 meters. Alright, so after 1 second, ball has gone up 20.1 meters. And this sort of makes sense to us, doesn't it? If it starts traveling 25 meters per second, right, after 1 second, we would assume its position to be around 20 somewhere. Remember also that as it's going up, it's slowing down, right? So, yes, this answer makes sense to us. Let's go with it. All right? Now, we're going to want to keep track of this because we're going to have a position at 1, 2, 3, 4, and 5 seconds. So I'm going to call this y1. That'll be y at 1 second. It is 20.1 meters per second. Okay? Now we're going to kind of want to organize this information as well. So let's bring this board over for our organization. So y1 at 1 second is going to be 20.1 meters. To find the others, we're just going to put 2 seconds in for t, do that calculation, then put 3 seconds in for t, do that calculation. And we will get some answers like so. Now is the time where you hit the L key and skip ahead 10 seconds. Yeah? Because I'm just writing on a whiteboard. And that's what we got. Now, before we move on, let's take a look at this in context of our diagram, and let's see. You know, these are supposed to describe the actual positions of this ball. Well, let's get a blue marker here. All right. One thing we can see is after 1 second, we're at about 20.1 meters. Another second, 30.4, and then 30.9. All right. I'm just going to kind of oddball the situation here. Just goes, okay, that's about, y1 is right about there. You know, this is in my way, and I'm not doing another take of this video. y2, we'll say, is right about here. Now, I kind of made that arbitrary. It's pretty easy to see that this is still the object moving upwards, but is the object still moving upwards at y2? Sorry to say, it could be coming back down through that. We definitely know this space is upwards because y1, y2 afterwards, but we don't really know. So I may or may not have been correct in putting y2 right there. It may be on the downward part. In fact, we can see this even more with y3 being at 30.9 meters. That's just a little bit higher than that. But again, is it on its way up or on its way back down? This data doesn't tell us that. So, one thing we'll see, y4 is definitely lower than y3, okay, at 21.5 meters. So we're looking at something like this for y4. Very clearly on its way down at this time. And then the fifth position, y5, would be somewhere maybe around here. Okay, so one thing we can see how the mathematics of this, the numbers that we get, describe something in the physical world. There should always be a physical idea attached to any of the math that we do for this class. Okay? Now, okay, so that's the first part of our problem, solving for the position. Let's take a look at the velocity now. Okay, so we want to find the velocity at the 5 different times for this as well. Okay? Well, we've got all kinds of information that we can use now. We can use the y positions at 1, 2, 3, 4, and 5 seconds as well. Right? That is new information that we've got. We can use that in our equations too. Now, remember, don't use a difficult equation when a simple one will do. And really, all we need for this is V naught plus GT. And notice that I am taking the old equations that we had where it was a here, but remember that we know this acceleration, it is g, it is the acceleration due to gravity. In the context of this reference frame, remember it is negative 9.80 meters per second squared. Okay, so we know V naught, 25.0 meters per second. We know A, or G in this case, and we'll also know the times. So again, just one example. V is equal to 25.0 meters per second plus negative 9.80 meters per second squared times 1 second. And so V, well, remember, we'll just call this V1, is going to be 15.2 meters per second. So after 1 second, it has lost 9.80 meters per second of velocity, right? Because it's going to change in the downward direction every second that much. So that's what we would expect. And you probably see we just have 25 meters per second minus 9.80 meters per second. Okay? So we get this for V1. Again, I'll put this up over on our other board. Feel free to skip through this while I write it up here. So and this is what we have for the velocities of each of these points. Now, we can actually give a definitive statement about whether or not y2 and y3 are on their way up or on their way down. If the y position at 2 seconds is 30.4 meters, and we can see that the velocity is, who cares what the number is, we see that it's positive, meaning that it is still on its way up. So I was correct to place it right here on the upward trajectory path of this. If we look at y3, which I haven't placed yet and didn't want to until we did this, we'll see that y3's velocity, the velocity at 3 seconds, is negative. It is now in the downward direction. So now I know, okay, it's still a little bit higher than it was at 1 second earlier, but not much. But now we know it is definitely on its way down when it gets there. And we can see the speed in the downward direction is increasing as it goes. Until we get here, we get to negative 24.0 meters per second. Now, this begs the question of, well, what do you think the velocity is going to be when it hits the ground again? Right? Where it started from. Okay? So, we've got this. We've seen that position data doesn't really tell us anything about the direction of motion at this point, but the velocity data comes in and fills in the gaps that we didn't know before.